Hi, and thanks for watching today. This is our Unit 7, Day 2 set of notes for Algebra Honors. So Unit 7 is our unit on polynomials, and Day 2 we're going to be talking about multiplying binomials. So binomials, again, are expressions that have exactly two terms. Remember, terms are things that are separated by adding or subtracting. So you'll see a plus sign or a minus sign in between terms. When we're multiplying two binomials, each term of the first binomial has to be multiplied times each term of the second binomial. So you really end up with 4 different multiplications. You can actually largely do these multiplications in any order, and so we are going to show 3 basic methods to multiply two binomials. So the first method I'm going to show you is using distributive property. You have used distributive property in the past, but usually with only one term. So we're going to say distributive property, and then the next method we're going to use, the next method we're going to use, it's called FOIL, and it actually stands for first, outside, inside, last. That's where we get FOIL. Okay, finally, we'll show you a box method that will work. And the box method would actually work for multiplying binomials times other polynomials as well. Box method. FOIL only works if you have 2 binomials. Sorry. All right, so just a quick reminder, here's a binomial, 2x plus 3. Okay, I have 2 different terms. So if we use the distributive property, we have some binomial, something plus something. So it's a binomial because it's got 2 terms. We're multiplying it by another binomial where we have 2 terms. One is C and one is D. Using the distributive property, I'm going to multiply A times everybody over here. And I'm also going to multiply B times everybody over here. Okay, so distributing anything that is on the left of our expression to all of the terms inside our expression. All right, so you can see if I multiply A times C plus A times D, that's where I'm going to have A times C plus A times D. So now I'm just distributing it out, right? Plus B times C plus B times D. Okay, so what we're going to do is we are going to start with the first term of the first binomial and distribute it through. I am missing nope, I guess example 1, I'm multiplying just a single monomial times a binomial. Sorry, looking ahead. So we're going to use distributive property on a monomial times a binomial here. So this is the only term I have that I'm going to multiply times the first and second terms inside my new expression. Okay, so negative 4x times 2x. I know I can multiply those numbers together. Negative 4 times 2 is negative 8, and it's still times x. I'm going to use distributive property, so I'm going to multiply negative 4 times negative 5. Excuse me, I'm multiplying negative 4x times negative 5, but the numbers I'm multiplying are negative 4 times negative 5, which gives me positive 20, and it's still times x. I hope I said negative 8x squared. I hope that's what I said. That's not what I wrote. Negative 4x times 2x, I multiply my numbers together, and I get negative 8. And then when I multiply x times x, I get x squared. Okay, over here, this is our new event. We're going to have a binomial times a binomial. So I'm going to multiply my first term of the first binomial. I'm going to distribute that to everybody in the second binomial. Okay, so it's really x times x minus 3, right? And then I'm going to combine it with my second term. Just for kicks, I'm actually going to use a second color. My second term, that 2 times the first term and then the second term, in my binomial. Okay, so My second term is 2. I'm going to multiply 2 times x minus 3. Okay, so now I just have two different distribution problems. So I have x times x, that's x squared, and then x times negative 3 is going to be negative 3x. Plus, here I have 2 times x, and I have 2 times negative 3 is negative 6. Of course, I want to combine my like terms if I have any, and I can see that I have negative 3x and I have positive 2x. So make sure you don't lose the signs of your coefficients. Just be careful there. I'm left with x squared minus x minus 6 as my answer. Okay, so we've just multiplied two binomials together using the distributive property. Let's do this again. Okay, remember I take the first term of my first binomial, and I'm going to multiply it times the second binomial. So I'm going to say it's 2x times 5x plus 8. Then I'm going to take the second term of my first binomial. So I'm going to combine this with 3 times 5x plus 8. Okay, first term of first binomial, second term of first binomial. And now we just use distributive property. So 2x times 5x, I can multiply 2 times 5 and I get 10. X times x is x squared. 2x times 8, I can multiply 2 times 8, so I get 16, and it's still times x. Here I have 3 times 5x, so I have 15 times x. And I have 3 times 8. 3 times 8 is 24. I want to combine like terms, and I want to make sure I don't lose any signs. So I'm going to be left with 10x squared plus 31x plus 24. Okay. All right. Over here, be careful because we've got negatives in here, and it just means that my first term is 4x of my first binomial, right? My second term is negative 1. Remember that negative is glued to the number that follows it, or the variable that follows it. So I'm going to multiply 4x times my second binomial, and I'm going to combine it with negative 1 times my second binomial. Okay, if you want to just keep in mind 4x minus 1 is the same exact thing as 4x, slide over, plus negative 1, right? So that's essentially what I did. I broke that up and made it plus a negative 1. It's just a little easier to keep track of those negatives this way. Okay, now I'm going to use distributive property. So 4x times 3x is 12x squared. 4x times 5, I get to multiply 4 times 5, and that's 20, but it's still times x because I have x there. Plus, this is going to be negative 1 times 3x. I'm putting it in parentheses, so negative 1 times 3x. I'm putting it in parentheses because otherwise it looks odd to have plus minus side by side. It just starts looking confusing. Okay, negative 1 times 3x is negative 3x, and negative 1 times 5, I'm going to go ahead and just write that as minus 5, but I could write it as plus negative 5 if I wanted. All right, now I'm going to combine like terms. So I have 20x and I have negative 3x. That's what I'm combining. So I have 12x squared. 20 minus 3 is 17. So this is going to be plus 17x and then minus 5 as my answer. Okay. All right, so I flipped my page over. We have practiced using the distributive property method to multiply two binomials, and now we're going to use FOIL. So the thing is about FOIL you can only use when you're multiplying two binomials. Okay, remember when we just did the distributive property, our first example, we actually had a monomial times a binomial. You couldn't do that with FOIL, so you have to have just two binomials. Okay, again, F is for first. O is for either outer or outside. I think I go back and forth. First, outer, inside, and last. That's where we get our letters. First, outer, inside, last. Okay, so I'm going to have two binomials, and I'm just going to jump away from our example on the paper, but I have two binomials. This is my first, and this is my first, right? I have two firsts, two first terms. I'm going to multiply the first terms together. So I have 4x times 2x. Okay, now I'm going to multiply my outers. So I have, this is, like if I imagine that this is the inside of this whole big box expression, 2 and 2x are on the inside, right? On the outside I have 4x and 5. So I'm going to multiply my outers together. I'm combining everything after I multiply. So outers, I'm going to multiply 4x times 5. So this is my firsts. This is my outers. My inners, I want the inside of this whole big mess that I've got, right? So it's going to be 2 times 2x. So those are my inners. And then my lasts are going to be the last terms from each binomial. So I have a 2 and I have a 5. So it's 2 times 5. That is the only time you're ever going to see me write it all out like that. So first, I have 4 times 2 is 8. X times x is x squared. My outers, I had 4x times 5, so I have 20x. My inners, I had 2 times 2x, so I have 4x. And my lasts, I had 2 times 5, so I had 10. And of course, I want to combine like terms. So I have 8x squared plus 24x plus 10. And I am sorry for encroaching on my next problem like that. Okay. So example 2, I'm going to do it again, but I'm not going to write out firsts, outers, inners, and lasts. Okay, so my first 2 terms, I'm going to say x times x. My outers, I have 1x times negative 3, right? So I'm going to say I'm combining 1x times negative 3. Then I want my inners, 2 and an x, so I have 2 times x. And I want my lasts. My lasts are 2 times negative 3. All right, now when I do all of that math, I have x squared minus 3x plus 2x minus 6. I'm going to combine like terms, so I end up with x squared minus x minus 6 as my final combined all neat and orderly answer. I do want to make sure that I have these in standard form, so I want my variables to be alphabetical. Typically, in these problems, we're just going to have one variable, but not only. And then I want highest exponent first. Okay, so if I solve this, first, it's going to be 2x times 5x, 2x times 5x, right? Firsts. My outer, it's 2x times 8. So 2x times 8. My inner is going to be negative 3 times 5x. And then my lasts, it's going to be negative 3 times 8. Okay, so 2 times 5 is 10. X times x is x squared plus 16x minus 15x minus 24. Combine like terms, and I get 10x squared plus x minus 24. Okay, so I'm going to probably start doing this less step by step. I'm going to show you what that looks like when I do it, but you're welcome to write out all the steps as long as it is helpful to you. So I know my firsts, it's 4x times 3x. So 4 times 3 is 12, x times x is x squared. I'm just going to do the firsts right now. 4x times 3x is 12x squared. Those are my firsts. My outer, I have 4x times negative 5. That's negative 20x. Okay, first, outer. My inner is negative 1 times 3x, so that's negative 3x. And then my lasts, I have negative 1 times negative 5, so it's positive 5. So again, make sure you don't lose any negatives. Okay, so this time I didn't write down exactly what I was doing, but I still did. I multiplied my first 2 terms together. That's how I got that guy, right? And then outer, and then inner, and then last. I'm going to combine like terms, so I have 12x squared, minus 23x plus 5. All right. So, example 5 is a big deal example. because I'm going to walk you through it and you're going to nod your head and think, sure, no problem, I would never make a careless error on this, but, oh, sorry. But just super cautions because there are errors to be made. Here, you know that this really means to say x plus 3 times x plus 3. Okay, so I'm going to beg you to write it out like this, please, because otherwise there are mistakes that will happen. Okay, my firsts, I have x times x, that's x squared. Those are my firsts, right? X times 3, this is my outer, so I have 3x. Yeah, x times 3 is my outer. My inner is also 3x. And then my lasts, I have 3 times 3. And so when I simplify, I'm going to get x squared plus 6x plus 9. Okay, please, 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 please be careful. Please be careful. Here's what the answer is not. Okay, here's what the answer is not. Just absolutely no, 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 no. If I have x plus 3 and it's x plus 3, or excuse me, x plus 3 squared, it is not x squared plus 9. It's not. Do you see that? It's not. You missed a whole center term. So just be super, super careful there. Okay. All right. K minus 2, all of that squared, I am going to write it as k minus 2 times k minus 2. My firsts are k times k, so I get k squared. Outer is negative 2k. Inner is also negative 2k. And then last, negative 2 times negative 2 is positive 4. Okay, so I end up with k squared minus 4k plus 4 as my answer. Okay, we can make some generalizations when we are just squaring some sort of a binomial, but you just want to be super, super, super careful. Okay, also this guy, same thing here. This guy is not, so I'm going to write not, right? It's not k squared minus 2 squared. So it's not k squared minus 4. It's not k squared plus 4. Absolutely no. No. Okay. All right, thank you. I'm going to stop the video now and then do the rest of the notes on a second video. Thanks for watching.